Hello, welcome back. So in this part, I'm going to tell you how to design a knowledge base using a technique called competency questions. So the task that you want to solve is you want to design a knowledge base, a knowledge graph for a specific application. Now you want to build some kind of AI system. Now, the issue that you now have is that knowledge graphs are sort of always extendable. They are kind of organic. They can integrate new knowledge. And this is sort of the exact opposite to how you work with a relational database. If you ever took a database course or you work with relational databases, you know that you do a lot of upfront work in designing the schema. And then the schema stays sort of fixed for the specific application. And you know it's very hard, very expensive, very complicated to later make changes to a relational database schema and correctly migrating the data and the applications and so on. So one of the big advantages of knowledge graphs is that you can sort of always extend them. You can add new edges. You can connect them to other graphs. And this gives you a lot of the flexibility of this knowledge representation. However, the downside or the challenge that you now have is how do you start designing a graph? You can't say, okay, let's just do nothing. Let's hope for the best and see if it works. That is sort of not a good approach, especially if you think of that these knowledge graphs become very big as well. If you're storing hundreds of millions or even billions of triples, you better have an idea on how you structure the graph. Also, you probably have a certain application in mind. For example, you want to build a chatbot that can answer certain questions. So you have to be sure that the graph that you develop actually works for the application that you have in mind. So that's the core idea of a design methodology that's called competency questions. Essentially, what you do is you start writing down a number of questions that your knowledge base, your knowledge graph has to be able to answer. So the steps are basically first, you think of a number of questions. I'll show you some examples in a minute. And then if you design the knowledge base properly, it has to be possible to answer these questions. So as a software design, software engineering methodology, you can understand them as kind of the requirement specification for the knowledge graph. So let's say you're building an AI system for something university related, something we started doing with the exercises on the worksheet and the lab, and something that we'll continue doing in the project. Then you could come up with these competency questions here. For example, you want to be able to answer which courses are offered at a given university. So that here's a variable. For example, which courses are offered at Concordia University, or which courses are offered at McGill, and so on. Then another question could be which topics are covered by a course, which professors teach at a university, what are the prerequisites for a given course, and which universities offer courses that cover a topic X, like the topic machine learning or knowledge graphs. So after writing this down, you can then select the vocabulary and the structure of the graph. And during development, you can check if your graph is able to answer these questions. Note that all of these questions here almost all of them have a specific pattern. And the pattern is down here. We have a certain entity 1, an operation, and an entity 2. Like entity is course offered at university. And in fact, people looked at typical patterns for these competency questions and came up with these major patterns here that most competency questions fall in. So you can see the pattern here. This is pattern number 1 that I mostly had in the examples before. And the variables in here refer to either predicates, elements, classes, properties, and so on. So this gives you a good idea on the different categories of competency questions. So when you design them, you can try to fit your competency question into one of these patterns, and then see which part of the pattern is something that has to be matched by a variable in the graph. So that's sort of the first part. You are explicit about what your graph has to be able to answer. And you don't have to stop there. You can also use it after development as kind of a testing vehicle. Let's look at another example, which I took from the African wildlife ontology. You can see more details on this in the publication down here. So when they designed this ontology, one of the questions they want to be able to answer is, which plants eat animals? So how can you verify that after you designed the knowledge graph, that it's actually able to answer it? And one way of doing it is writing a Sparkle query. So essentially what you do is you translate your competency question into a Sparkle query that answers the competency question. In this case, you can see that there is a select query that checks for plants that eat animals. This entity here, eats, is a subclass of plant, and then the ontology is using OWL, which we haven't covered much, but you can see there are OWL properties and so on that check for the eat relationship. So this is a good systematic way of designing and testing knowledge graphs. So basically, when you start, you think about what the graph has to be able to answer. You write it down in form of competency questions. You look at the questions when you select vocabularies and build the structure of the graph. And you're writing Sparkle queries that serve as kind of test cases for the graph. So you have to be able to answer the question using a query from the graph. That's not the only technique. There is another technique that I'm not going to cover in the course, but you can have a look at it online. There is a technique called shapes constraint language, which allows you to describe properties of graphs and have it automatically checked using this language here. If you're interested, you can have a look at this publication where I also took the DBpedia knowledge base creation process out earlier. And they describe how they build DBpedia using this approach. And they also explain how to use this shaped constraint language for some of the tests on DBpedia. But what we are going to do here for this course and for the project is the approach of writing down competency questions and testing it with a Sparkle query. And as a first small exercise, please go to the worksheet and work on task number 5, where you have to write a simple competency question and a corresponding Sparkle query. And I'll see you in the next lecture part. Bye-bye.